Hey guys, it's Miss Landry, and today we're going to learn all about data. This is lesson, I believe it's 1.4. So we've already learned about variables, we've learned about constant and controls, and now we're going to learn about what to do with all the data that you collect. And if you don't know who this guy is in the corner, that is Data from Star Trek. If you don't know, well, you're going to have to watch it. All right, so let's start with the types of data. Make sure that you have your guided notes. There's two types of data, and then that is broken down even further. But let's start with the two main types. The first type is quantitative, and I want you to think about what that word means. Okay, think quantity. That means numbers. That means this is measured, it's numerical, measured. And this is what in science is preferred. So if there's a way to collect numerical or measured data, that is what you want to do for sure. Okay. Then there is qualitative. Now, sometimes you can't collect data, and that's okay. We do want to, I'm sorry, I back up. You can't collect quantitative data. And that happens sometimes, and that's okay. So, what we do instead is we collect qualitative data. And again, think about this word quality. What quality does it have? So, this type of data is going to be based on your senses. So, it'll be things like colors, smells, not taste in the lab. It could be something like, is it soft? Is it rough? Okay, so that would be a quality of what you're looking at. This is not measured. It tends to be subjective, meaning you might have a different opinion about what you think is rough than I do. And therefore, that's why we prefer the measured data a little bit more. Now, with that, I want to go a little further and break it down even more. So if we look at qualitative data, sorry, I got to get my pen back out. I'm going to change colors though. Let's go yellow. So qualitative, remember, means quality. These are your senses. And there's two types of qualitative data. There's ordinal, which means ordered. Now notice it says test grade. This is a little bit confusing, but here we're talking about letter grades like A, B, C, D. If we were talking about your actual score, like what percent you got, that would be quantitative data. Your qualitative data can also be nominal. So this is when it's not ordered. So this would be categories, right? So like colors of cars, or it could be what country you're from, maybe the flavor of ice cream you prefer. There's not a specific ordered way to categorize that. Now let's look at quantitative. So remember, quantitative means quantity. These are numbers, these are measured, okay? And the first one I want you to know is continuous. So continuous data is like height or distance. These are things that there's no break in between and it can be divided pretty easily, right? So continuous would be something, time is a great example. A quantitative data set can also be discrete, which means it can't be decided. So, for example, this is when you count. So, how many cats does Miss Landry have? Yeah, two. So there's not any number in between there. I have two cats. Okay, so that would be an example. It's still a number, it's still measured, it's counted, but it's not a continuous amount. I hope that makes sense. And yes, I do have two cats. So now let's take a look at clear screen. On your worksheet, you guys have a question. And the first question, and we're going to go over two together, and then we're going to go over the answers. So the first one says, John is 6'4". What type of data is this? So if you think about it, first of all, it's measured. So we know that it's quantitative. And height, like I said, is continuous. So we're going to call this quantitative continuous. Now look at your worksheet again. Let's take a look at B. John has brown hair. Notice brown is something you got with your senses, with your sight. That is a qualitative, it's the quality of his hair. And it is nominal, meaning brown, blonde, red. It's not a continuous qualitative trait. I'm not going to go over the other two. The answers are qualitative nominal and quantitative continuous. Hopefully you guys got that. All right, let's talk about when we collect data. We actually talked last class about what a data table should look like. Remember that your independent variable will always be that first column, and then you'll either have your dependent variables or your trials, okay, just like I show here in this graph. And I want to make sure that you understand that this part right here is actually what we graph. If we have a number of trials, we're going to graph the average of those trials. Okay, so a lot of times students will try to graph all the trials, and that gets really messy. So you're going to calculate the averages of each trial together, and you're going to take a look and see and graph that. All right, presenting data. Let's talk about what your graph should look like, okay? First of all, and this is a lot, so I'm going to go over it pretty quickly, and then we're going to go through each one. So you definitely have to have a title. I'm going to highlight what I expect you to have in every single graph. So title is number one, okay? You absolutely have to have a title, and we're going to go over we're going to practice getting some good ones. You need to have an axis title or a label, as I call it. Okay, so what is your independent variable? What is your dependent variable? Both X and Y need to be labeled. So that's number two. Number three, you have to have your units. So if you notice here, this is the units are right here. Here's the units here as well. It's okay if you don't know what those are. And we'll talk, like I said, again about that. And then finally, you need to have, well, I think I'll show you on the next line if that's okay. You don't need to have an equation. I am not going to ask you guys to come up with a trend line equation. I am going to show you how to do a trend line on probably Google Sheets, since that's what most of us use. Okay, so those are the three things that are absolutely required. Each one of those, if you're missing it, you're going to lose a lot of points. So let's move on. Whoops. Trying to make this graph or this video pretty fast. All right, let's go over types of graphs. So the one before this, let me go back. Sorry. Trying to go back. No, go back. There we go. This is called a line graph or a scatter plot. So if you notice the little blue dots that are all on here, those are your data points. And then the green line is what is calculated. So that's what we call the trend line or the line of best fit. It shows you kind of where that data is going. This is the type of graph we're probably going to use the most, is this scatter plot along with a best fit line. Now, most students don't realize there's a difference between a bar graph and a histogram, and you do need to know the difference. So notice on the bar graph that the categories are not continuous. Do you see how these are, I believe, what we called nominal? I don't know, I can't remember. But there's no continuous point. So there's spaces in between to indicate that there's nothing that's in between it. You can either be in the United States or in India, but you can't be in both. Okay. Versus a histogram, notice there's no gaps between the bars. And that's because this x-axis is what we call a continuum. So the data is kind of throughout that entire continuum. And we'll practice this. So if you're not getting this, don't worry. I promise we'll go over this. The other type of graph I want you to know, I don't love this type of graph, but it is useful, is a pie chart. You guys have all probably seen pie charts. I do want to show you a bad pie chart. So the thing about pie charts is that they're really used to show how much something is of the whole, right? So like if I have 3 slices of pizza, I had 3 out of 8, right? So, it kind of shows you a ratio basically. But sometimes people put too much data on their graphs. Like this pie chart tells me absolutely nothing. It is just a big fat waste of time. So please do not put that much data on a pie chart. It is, ugh, it's like nails on a chalkboard. Okay, so one more time, what do you have to have on every graph? And I'm telling you, you will absolutely lose points if you're missing this. First of all, title should explain the 2 variables. So if you remember our example of Cheetos and hip circumference, you have to have both variables. So the number of Cheetos eaten daily compared to or versus the percent change in hip circumference would be a great title for a graph. I have seen students label their graph biology lab graph. Please don't do that. If you do that, we're going to have a talk. Two, labels. We talked about this. Both axes should be labeled. Your y-axis is your dependent variable. Your x-axis will be your independent, or it'll be time depending on the type of graph you have. Don't forget your units, okay? Imagine if I said to you, all right, if you get this right, I'll give you 50. And you're like, 50 what? $50? 50 points? 50 extra credit points? No, you don't know because I didn't tell you what units I'm talking about. And so if you don't put that on your graph is useless. You also need to have uniform spacing, and I'm going to show you an equation to figure this out. But basically, every little square on your graph paper should be the same amount of distance from each other. I've seen graphs where kids will go like 20, 30, 75, 77, and that's not the way to graph. Like, you don't graph your data on the x-axis, if that makes sense. And again, we'll talk about this. And finally, if you are using time on the x-axis, that means you're probably going to have multiple lines on your graph, and you need to include a key. So what does each line represent, right? It could be the group that had 10 Cheetos a day. That's one color. The group that had 30 Cheetos a day, that's a different color. And again, we will practice this. That's only used when time is on the x-axis because you're not graphing your independent on the x-axis. So one last thing I want to talk about is why we graph. And we graph so that we can predict, okay? And there's two types of predictions that you can use with your graph. You can either interpolate, which is a weird word. Inter, though, means inside of, right? So interpolating means you're predicting within your data set, so within what you collected. Most often what we do is we extrapolate, and extra means outside of, okay? And so that is when we're basically going to extrapolate outside of our data. So if you look at this little diagram here, you can see that extrapolating, so if this right here is my data, so I collected these, looks like 7 points, okay? So my data is in that range. If I predict anything within this range, that's interpolating. But if I predict something outside of my data using that line of best fit or that trend line, we call that extrapolating. So let's try a little practice just to see how you're doing. So here's, oops, let me clear that. Here's a graph. It's a real simple graph. Temperature of the day and sales in dollars, okay? So if I said to you, I want you to extrapolate what the sales would be if the temperature were 94 degrees. Okay, so I'm going to move this over. Notice that my data ends at 90 degrees, right? Sorry, I'm trying to get a pen. So here's my data. It ends at 90. So if I'm trying to say 94, I would draw a line up to where it crosses that best fit line or the trend. It's really hard for me to draw a straight line, so bear with me. And I would draw a line across. Now you can't see it because my face is in the way, but my sales would be hopefully around maybe what, $158. That's extrapolating because it's outside our data. But if I said to you, okay, well, yesterday was 83 degrees, what is our predicted sales? I would go right to 83 and cut across, and I would say it would be about $100, and that would be interpolating because it's within the data that I have collected. That is it. That was a long video, but hopefully it made sense. Hopefully you took your notes, and I'll see you guys later. Thanks, guys.